Good afternoon. My name is Bill Couch. I work on the web client for Periscope.tv.
Yeah, and I'm Peter Jan Speelmans. Pretty difficult to say in English, but I'm CEO and one of the co-founders of TheoPlayer.
We're going to talk to you today about enabling live video everywhere, and specifically how Periscope is using HTML5 video and HLS to enable that. So earlier this summer, you may have heard about a sit-in that occurred in Congress. The House Democrats staged this sit-in to insist on a vote for a gun control measure. They intended their protest to be broadcast on traditional media and to the public through the cameras that are available in Congress. However, the House Republicans control Congress right now, and they decided to declare a recess when this protest was occurring. During a recess, all of the cameras in Congress are turned off. This meant that media outlets didn't have their way to be able to broadcast what was occurring inside of Congress. However, House Representative Scott Peters turned to his iPhone and started broadcasting the events on Periscope. His broadcast started spreading rapidly online, and C-SPAN very quickly picked up on this as well. And they started rebroadcasting the feed from our website on Periscope TV that Scott Peters was presenting. And here was a clip from that broadcast.
There's an app called Periscope, and I understand if so many people watch it, that it crashes. And so that if other people had it and wanted to download it, maybe they would like to try it out too, and would generate a little bit more capacity for the effort.
There's an app called Periscope. It's, of course, you're talking to Mr.
I said that.
An app called Periscope that if people were to turn on, download it, that Scott recommends that that's what you're doing for some technological reason beyond my capability of explaining.
And by the way, we also did a motion to suspend the rules, which was unanimously adopted, so we could film.
I made the motion.
Yep, Mr. Butter.
All right, Lois Frankel, followed by Hank Morgan, followed by Bobby Rush, and then the next four after that will be Debbie Wasserman Schultz, Peter DeFazio, John Sarbanes, and Steve Israel.
So what's kind of hard to see here is that C-SPAN has actually cropped what you're seeing on Periscope.tv, but this was actually being broadcast directly from our site. And the reason he said that our app was crashing a lot was he was getting a lot of phone calls from friends and family telling him he was on C-SPAN right then, which was interrupting his broadcast and killing off the feed. But what was unique about that moment was C-SPAN was airing Periscope.tv, which was powered by HTML5 and JavaScript, and that was powering C-SPAN right then. So people were watching this protest from their phones, on their computers, and on live television, all in real time. And what was substantial about that was that anyone was able to watch this live and from everywhere. So if it's possible to do that, why not do that?
Yeah, and that's a real good question. I mean, if you can actually run HTML5 everywhere, like the C-SPAN example shows, then why not just do it? I mean, over the last years, there's been a clear move from Flash towards HTML5, and it started a lot of years ago when Steve Jobs published in 2010, when he published his thoughts on Flash, outlining why Flash would never run on iOS devices. That was definitely a first moment when HTML5 got that attention. But also last year, for example, when Mozilla decided to shut down Flash in their Firefox browser because of all the security issues that were there at that moment, that was a real wake-up call for a lot of publishers. And then at that moment, they realized that Flash was not going to be around forever and that they really needed to find a solution. And HTML5 is a real good solution for that. I mean, it's available on almost any platform. And well, you can't say that again. You can't say that anymore about Flash. I mean, more and more vendors of browsers are actually limiting their Flash support, are announcing it to be removed completely from those browsers, even though Flash was, for a very, very long time, the industry standard for distributing video. But these days, you can also do it in HTML5, because HTML5, it really allows you to do a lot of stuff already. In the beginning, it was a lot more limited. It was only video on demand that you could do across all the different platforms. But at this moment, in the past few years, the Media Source Extensions API got introduced. And this API, it actually allows you to feed a bit stream to the media decoders, which are available in the browser anyway. And it allows you to load chunks of video, pass them on to the decoder, have them played back, and just repeat that process and actually implement a complete streaming solution in HTML5. And these APIs, even though they're fairly recent, they're available already in almost any common browser. You have all the big ones like Chrome and Firefox and Microsoft Edge. There are a few notable exceptions. For example, the iOS platform, it doesn't have this API. And the same goes for older browsers like Internet Explorer 10 or Internet Explorer 11 on Windows 7. But even on those platforms, there are ways around it that will allow you to do streaming on those platforms. It requires a little bit more creativity and some more advanced algorithms, but it's possible on actually any device. It's not all well with HTML5 and streaming, though. MSE made a lot possible, but there's still a lot of differences in between different platforms. In the beginning of HTML5, there was already the difference between which media formats were supported in different browsers, with differences between MP4 and WebM being available. And even though it's standardized at this moment to H.264 and MP4s, in the future it might become a new problem. There are differences for the next generation of video codecs where H.265 or HEVC is supported in some browsers, while other browsers, they don't want to support HEVC, but they're supporting VP9 instead and don't really have plans to support HEVC. That's just one thing that's making it very clear that there are differences, but there are actually other differences as well, and there are differences that you don't really notice until you really get into it. There are differences, for example, in implementation. If you take a look at the Safari browser, all the timing information that it's using to calculate durations of videos, durations of video frames, they're using presentation timestamps for that. And a presentation timestamp, it just tells you when should a certain image be shown, when should a certain fragment of audio be sent to the speakers so that a user can hear them. Other browsers don't tend to do that. Other browsers took, from a technical standpoint, a slightly easier method. And what they're doing is they're using decoding timestamps. A decoding timestamp is basically the timestamp that tells you when a certain chunk of data should be sent to a media decoder so that it can be transformed into an image which can later be shown. And even though those timestamps can be fairly similar, they're not the same. I mean, there can be differences. And as a result, you can have a video stream that's running fine on most of your browsers. But then once you start playing it back in a different browser in HTML5, all of a sudden you're bumping into these problems. The images are a little bit jerky. It doesn't play smooth, and it isn't giving the user experience that you had expected. And the codecs, it's a clear difference. The implementations, it's obvious between browsers that you're going to have different methods of doing things. But even within a single browser and within a single browser version, you can still have differences in between the different platforms that the browser is actually running on. And often it's related, for example, to the way how the media decoders, which are available on the platform, are actually handling things. A great example of that we actually found when we were working together with Periscope. It's how certain encoders and certain decoders handle things. If you take a look at GoPro cameras, the encoders on those cameras, what they actually do is they output some 0 bytes at the end of the network access layer units. For non-technical people, those are just building blocks that allow you to build like a video frame. But those 0 bytes at the end, they're perfectly legal within the H.264 specification But if you pass that information on to certain decoders, those decoders will start misbehaving or doing stuff that you didn't expect. And as a result, you can have a Chrome browser of a certain version running on Android, running on Chrome, running on Mac, and everything is showing fine. But then once you open that same stream in the same version of Chrome on a different platform like Windows, all of a sudden, it stops. And you don't know why. There's no clear explanation why this is going on. But then it's usually related to tiny differences in the platforms, like with those media decoders. And at TheoPlayer, we've seen a lot of those differences. I mean, we've worked together with almost 1,000 different publishers so far, seen a lot of different encoders, a lot of different packagers, a lot of different configurations. And every once in a while, we still bump into this one case where one platform for a certain browser is not outputting it the way it should. And it's just new stuff that you need to handle. And it's something that most people tend to forget because they think, well, HTML5 is like a magical bullet and it'll solve all your problems, make sure that you can run it everywhere. And you can, but you really need to keep it in mind when you're developing a player or when you're using a player. You really should test those things and handle those things. But once you do, I mean, it really becomes possible to get your HTML5 video available on any platform that's out there.
Yeah, one of the things that's been unique in partnering with TheoPlayer and enabling playback on web for us is that Periscope has so many different devices that are performing the encoding. Originally, when we launched our GoPro integration, we were relying on the encoding from GoPro, and that was yet another source that we had to handle. So ensuring that a player can play back video encoded by all sorts of these different devices makes it a bit more complicated to ensure consistent playback, but we've ended up in a pretty good result now where almost all broadcasts are working beautifully on web in HTML5. So looking back at Periscope now, we've had over 200 million broadcasts since the platform was created, and that was just earlier this year, and it continues to grow tremendously. And then every day, we're seeing over 110 years of live video that are being watched on mobile devices alone. That's a lot of live video to serve. It is the equivalent of one person watching video since 1906 live continuously, but per day. So we do a lot of work to ensure that people can watch those broadcasts in any browser and on any device, as Peter Jan is discussing there. And then also importantly, in real time. So in order to enable that across all of these devices in real time, we have spent a lot of time figuring out how to make sure that that's possible. We care about real time, not only because it's a better experience for viewers, speed is a feature, but Periscope has some unique mechanics on how you watch a broadcast and the fact that you can actually participate in the broadcast. So here's a screenshot of Periscope.tv with everything that's kind of happening in a single broadcast. So this was a broadcast that I did out on Ocean Beach in San Francisco. And you can kind of see on the left there are comments that are rendered. And on the right are hearts. And they're not moving here, but when you're watching it live, they're all kind of animating up on the screen. And we render those in real time, synced with the video as they're occurring. So when someone posts a comment on their device and they send that comment, it is shown to everyone who is watching it and the broadcaster, synced to the video as they're watching it. We do this through writing NTP time to each message object, which can be a comment or a heart, and syncing that to NTP time that we also write to the video, which is encoded into the ID3 metadata timestamp. So through that, we're able to sync all of this activity and add a richer experience to the broadcast. What that then enables is viewers, so in order to send all of those comments and hearts in real time, we also want to make sure that the video is shown in real time as well. So we've worked really hard to make sure that that's possible. And we have done that now with some optimizations to HLS video. We did a little bit of research, and we found a way to actually provide real-time live video over HTTP with HLS in a way that is on par with the same latency seen as RTMP. Let's look at why this is important. We'll take an example where Peter Jan's over in Belgium, where he's from, and I'm in San Francisco. I'm an avid cyclist, and I start broadcasting from San Francisco during one of my bike rides. So video starts there. Peter Jan wants to join and see what I'm up to, and so he joins the broadcast, but when he joins the broadcast, he is getting video that's upwards of 10 seconds delayed from when I'm actually broadcasting it. What this means is if he wants to post a comment about what he's seeing video that's considerably delayed, so that comment is sent and it arrives to me long after now that that moment has passed. So if he wants to interact with me or influence the broadcast in some way, it's a little bit harder, it's a little bit incongruous, and it doesn't feel like a great experience. So by reducing the delay that we have when broadcasting video and bringing it down to speeds comparable to RTMP, we have a situation where the feedback loop is much tighter. Video arrives on his device, he's able to comment in real time and send that right back to me, and that feedback loop becomes much tighter, and he can actually influence the broadcast much more easily. And that's a really powerful thing about Periscope and why we've put a lot of time and energy into ensuring that the video can be as real time as possible. This means as well that we can close that gap for people to shape the experience in a broadcast across any device, whether they're on a phone or a tablet, mobile browser, anything there. And while that's useful for when I may be wanting to share a moment like broadcasting while I'm on my bike ride in San Francisco, it's even more important in moments when Congress is having a sit-in and there's a protest and people want to send comments or hearts and provide that feedback there and potentially influence situations like that. We also see people broadcasting from Mosul right now with commenters being able to provide support and ask questions and get real-time feedback about what's happening from people on the ground there. So when you can participate in these moments from anywhere, you're able to experience live video everywhere. And so we're kind of wondering if live video is possible, why everywhere, why not do it? That's more or less our rundown. This is our contact info. If you want to get in touch with us, we also, TheoPlayer has a booth over at 214, so you can find us there. But we also have time open now for questions.
Yeah, I think we went a little bit fast, so more time for questions anyway. Yeah?
I'm not a Periscope user. I sort of heard about it for the week today, believe it or not. And how do you monetize content that you don't control? Like, how do you monetize the bicycle ride? Who's paying for it?
Yeah, that's a good question. Right now, so Twitter owns Periscope right now, so that's something that we have been focusing mostly on the experience of watching live video and all of the mechanics that are in there. We're working on some advancements of other features. We'll have more to talk about on that soon, but we can't quite dive into that right now.
Kind of twofold question. What kind of latency are you guys actually getting? And to high level, what have been your approaches to reduce that latency with HLS to bring it into the RTP space?
Yeah, we're seeing it get down to 2 to 3 seconds, comparable to RTMP. How we're doing that, that's something we are very close to having more details on, but we can't quite talk on that just yet, so we'll be in touch. You'll see, if you follow us on online, you can see when we announce what's going on there.
I'm driving around internationally. There's an issue on privacy.
Mm-hmm.
Also, white labeling. You have a program where you white label these particular platforms?
So we have some other ways that you can broadcast. Not necessarily, it would still happen through Periscope, but you can broadcast without a mobile device now as well. We've announced external encoder support. So you can use OBV programs to pipe in anything, and you can make it much more produced and have something that is a bit more representative of something that you would own instead of necessarily having to be on a mobile device with that. But as far as that's concerned, that's about what we offer there.
Any comments on scaling? So you mentioned the 2 to 3 seconds of latency. How does that scale, and have you tested it at various scaling levels?
Yeah, 2 to 3 is what we see in best case scenarios, but it can extend a little bit longer depending on where someone is in the world. And we use AWS and have support in a variety of our regions, and so that can depend based on where someone is tuning in from. But we've been able to even see it not get too much higher than that across large spans of distance. Yes?
How do you deal with, how do you scale the comments, the feedback that comes back to you? If something is highly popular, would you not just see essentially a wall of text comments flying through?
Yeah, there's a lot of mechanics that we have in the clients to render those. Almost all of the comments do get rendered, but they can get dropped if there are too many, and there are very specific mechanics on the timing for how long each comment sits on screen before it gets pushed out. If there are a lot coming in, they'll stay on the screen for less amount of time. It's kind of a race between how many are showing up versus how long before they're going to be at the top of the screen, and then we just start fading them out from there. But in terms of a service, we've actually built our own internal service to handle all of that commenting, and that's a whole nother thing to dive into on how that's all working. So I'm happy to discuss more afterwards on what that looks like. Yes?
So how do you get around the data limitations? Do you have like a Wi-Fi extender?
In terms of providing bandwidth for people to be able to do these broadcasts, it's one of the things we're continuing to work on improvements of, both for broadcasting and watching, because it can be a lot of bandwidth processing through on someone's device. So it's pretty good right now. It's better than what you would find for a lot of live streaming platforms, but we're continuing to make improvements there. Yes? I'm sorry, say that again?
The role of the CDN.
They sit in front of a lot of things, both for, we have it sitting in front of our site, we have it sitting in our video processing stack. We use Fastly, but they are, it sits there and reduces a lot of the burden that we have, but it is not very prohibitive for us to be able to provide everything real time. We've done a lot of optimizations and configurations, or optimize our configuration rather for the CDN to make sure that everything stays in a pretty tight feedback loop there. Yes?
Yeah, what's your sort of typical viewing time?
It really can vary across platforms. I don't have exact numbers on that right now, but in terms of what I was mentioning earlier per day, we do see 110 years of video watched per day. And I think we've got upwards of a couple minutes on mobile devices. And on web, we're still aggregating some of that information. I thought I saw someone over there. Yes? Yeah, that's something that we're working on as well with that. The tighter you make that latency, the more opportunity there is for buffering. So far, and what we've been doing, what we've seen so far is that it's been quite good, but we need to do more testing across various inclement situations. But it's actually been quite good. There's a bit of work that TheoPlayer has done as well to make sure that that isn't so much an issue when you have the buffer to be pretty, or when you have the latency to be pretty low. You go ahead. Right now, we only provide our streams in one quality level, and it has proved pretty successful so far, but we're looking into improvements there as well. Some of that stuff is things we'll have more details on soon. Yes. Yeah, we're always working on new things, and we can't quite comment on what's coming up ahead, but yeah, stay tuned. Yes?
Do you guys keep your streams in sync when two clients are watching, or is it just...
So it depends on the client when they are actually joining the broadcast. Again, like I was kind of discussing in the talk, they can come in at different points. They may not all be in sync, but the way we handle that and to make sure that everything does sit in sync is that we have time code written to the metadata of the video, and we also write that same time code to all of those message objects, which have types of comment or a heart, and they get rendered that way. And all of the clients actually, as they receive those events in real time, if that point in the video hasn't occurred yet, we buffer those events and then wait and process them once that time code has occurred. And so that effectively recreates the live playback of the comments and hearts with the video. That's also, again, why improving the latency makes all of that a little bit tighter and a little bit richer for people to be able to shape the broadcast. Yes?
Wouldn't that lead to the best experience for people who are furthest behind?
For people that are, if they want to participate, it's actually, that's when it gets worse. Because they, if I'm, say Peter Jan's watching this 10 minutes, or not 10 minutes, 10 seconds delayed, or let's say 30 seconds delayed because whatever conditions are present. If he wants to send a comment, he's going to send that, but it's going to have a time code with video that happened 30 seconds ago for the broadcaster. So we'll show it immediately and on the broadcaster's side, and that can be out of sync or like seem a little out of play from everyone else's comments that are more in sync with what's happening right there. So in terms of being able to participate, it's not as great. And because we do process them immediately if they are from the past, it's generally best if they're able to receive them in advance of, just short of advance of being when it's going to be shown, and then we play it all back. But overall, it tends to be, as we have seen across hundreds of broadcasts, like the experience is pretty nice, and people feel like they're really able to participate with the person broadcasting. When they acknowledge a comment that comes through, like the broadcaster says something or does something because the commenter said that, they get really excited because it's really weird to see video that you're generally accustomed to being recorded or happening in the past actually change because you did something, and especially from any device. Any other questions? We have a site, or our blog, medium.com/Periscope TV. Any announcements that we would be making would be published there. And you can also follow our Twitter feed, Periscope Co. And Periscope CO, and that will have details there. I know when we have more details to share, we'll probably at a point go in depth about some of the details on, technical details on how some of this is occurring. We're not quite ready yet to share that. Soon. Yeah. Yeah, I think I would assume probably by the end of the year, but we'll see where that falls. Yes.
Any plans
To open source? We don't quite have plans for that right now. For the latency stuff, I think when we have more details to share there, you'll be able to get a better sense of what possibilities there are for others with that as well. Yes? I don't think we really see differences with browsers on that.
Most browsers actually just work in the same way. What we do at TealPlayer is actually we make it one of the points to get a similar user experience in all the different browsers. So if you're on a mobile device or if you're on a desktop device, the experience for the user will always be very similar. So
Yeah.
there won't be a big difference in latency because, well, we control the entire pipeline, and we just make sure that all users have the same experience there.
And most of that's also, I think, going to fall on where that person's connecting from, the quality of their connection. I think those are going to be more of the players in determining that latency there. Yes?
On the mobile, do you also use HTML5 or use native app?
We are opening more on mobile browsers for HTML5 playback, but we also allow you to watch it in the app. So we have dedicated apps for the iPhone and Android. Right now we have full support for watching broadcasts on iPad, on mobile Safari. And I believe iOS and Android on tablet devices have pretty consistent playback, so you can watch them all there. But then you can also open them in the app if you have the apps on those devices and watch them there. We're fine-tuning some things as well to broaden the set of devices that's playing on, but it's all possible now with Theo Player as our video player.
From the video player perspective, what have been some bigger challenges on iOS without the user source extensions that you guys had to deal with for Periscope?
Yeah. Well, there are still possibilities to do streaming on iOS devices, even though there are no MSE capabilities. You can still talk to the hardware decoders there. It just requires you to do things a little bit more different. But all in all, I mean, it's part of our technology. It's the same, for example, if you try to go to Internet Explorer 10, there's absolutely no MSE there. And you can't even play out a standard HLS stream even if you would want to. But thanks to the technology that we actually developed, we can simulate an MSE-like environment in any HTML5 browser. So the limitation of not having MSE for us, it doesn't really matter. We can get the same experience on any device or platform.
Yes?
So even on your native apps, then you're using HLS throughout?
We are, it varies depending on, but we are using, when we launched, we were using RTMP for first set of users that joined, but that was difficult to scale for everyone that would want to watch it. RTMP is a bit more work to host and costly, so we, after that point, would then provide it in HLS to people who are joining the broadcast later. I believe now we are doing HLS across the board there. I would need to double check. We're fine-tuning that right now, and we kind of play with those numbers sometimes. So, but it's predominantly HLS on mobile devices as well. We use Exoplayer on Android and native video player in iOS, and we are working on some custom things as well for some of the stuff that we're doing ahead for bringing the latency down. Questions?
Yeah. Okay.
Go ahead.
I'm just curious, so Twitter's starting to do a lot of live streaming now for sporting events and all sorts of things. Is your technology tied in with them, or just two separate platforms?
Right now it's two separate platforms. Live video is one of the big initiatives that Twitter is focusing on right now, and Periscope we're right now treating as more for anyone to be able to broadcast live, for more user-based stuff, but for a lot of the sort of more premium content that's going through Twitter, and right now those stacks are relatively separate. We're tightening integrations in terms of tech that we use on top of that between the two, but right now they pretty much sit separately. Twitter acquired Periscope last March, and so we've been doing a lot of work to integrate the two, but they have started out as separate. Yeah, I think there's still work to be done on figuring out what makes the most sense there, but right now we want to be able to share what makes sense to, but keep what we need to separate as well. Anyone else?
No.
That's good.
Okay.
Chunk size, we're doing about 1 to 2 seconds. We keep it pretty small. We're finding that to be the best. We've played with that number a lot, and I know before we launched, we were We did a lot of fine tuning to that to make sure everything would be as fast as possible, and that's how we got it down to 10 seconds for launch. Part of it was configuration with our CDN, part of it was, at the time, Wowza, and the other part was, yeah, just tuning how we were authoring the manifests and the chunks. Yes? Right now, transmuxing only. Yeah.
And I guess we're done.
Yeah, we'll be over at booth
Yeah.
214, so if you have more questions, you can find us over there.
Yeah.
Thank you very much.